what controls lifespan? Why do some organisms live for centuries while others only a matter of weeks? Perhaps somewhat surprisingly, clams may hold the answers. Today, the longest lived animal on the planet is the bivalve, Arctica islandica. Off the coast of Iceland, this species can live for up to 507 years. But a little closer to home, off the coast of Long Island, it only lives for about 200 years. So what's the reason for this dramatic difference? The graph on the bottom left is the result of a global database of bivalve lifespans. It's clear that tropical settings are characterized by much shorter-lived species, whereas mid to high latitude settings are characterized by much longer-lived species. This suggests a role for the environment in longevity. Now, questions of longevity have long been an area of scientific investigation, and though there is much debate, one factor seems to be extremely important in promoting long life, and that's low metabolic rate. There are really two ways in which you can lower the metabolic rate of an organism. One is to decrease the temperature, and the other is to induce caloric restriction. Both factors are likely in play at high latitudes today. Water temperature decreases as we move towards the poles, and food availability, which for a clam is phytoplankton, becomes extremely seasonal due to the extended periods of no sunlight. If we could examine bivalves from a warm, high latitude setting, we could deconvolve the importance of temperature and food. Though no such location exists on the planet today, fossil deposits from Antarctica provide us such an opportunity. About 40 million years ago, as you can see from the image on the right, Antarctica was a much different looking place. Large stands of coniferous trees dominated the landscape, rodents and extinct elephant-like creatures roamed the forest, and temperatures resembled those of modern-day North Carolina. It's in this unique setting that we find several co-occurring, unrelated, long-lived species of bivalve. Cool temperatures cannot explain the longevities of these taxa. However, the high latitude setting would have resulted in extended periods of no food and suggests that caloric restriction may be the driving factor in extreme longevity. Bivalves have been on the planet for over 500 million years, but only a handful of studies have examined their lifespans from the fossil record. Questions such as, do lifespans of species change over geologic time? Or is lifespan a heritable trait? Are attainable with bivalves and may represent the next frontier for paleobiological research. Thanks.